Have you ever stopped to think about how your phone can grab your first initial, or how a website greets you by name? It feels a little like magic, doesn't it? Well, today, we're going to pull back the curtain and show you the trick. We're breaking down how computers actually read and handle text.
Right? It's one of those things we see every day. But believe me, it's not magic. Behind every one of those personalized greetings or text edits is a really simple, elegant system that lets a computer navigate words and sentences with perfect precision. And that's exactly what we're going to unpack today.
So first things first, we got to get on the same page as the computer. To us, we see words and sentences. But to a computer, text isn't just a random jumble of letters. It sees it as something very, very specific.
And that something is called a string. The best way to think about it is like houses on a street. A string is just an ordered line of characters. And every single character, a letter, a number, a symbol, even a blank space, has its own unique address.
Throughout this breakdown, our guide is going to be our friend, Sammy Shark. Now take a look at this. This is basically our map of the street. Every character has an address. And notice the most important part. Where does the numbering start? It starts at 0.
Okay, so we have our map. Now let's learn how to use those addresses to grab any single character we want. This whole process, it's called indexing.
The official word for that character's address is its index. And the tool we use to access it is super simple, a pair of square brackets. It's like telling the computer, hey, go to this address and tell me what character is living there.
Let's see it in action. Here, we've just kind of packed our string into a little box called SS. So when we write SS squared bracket 0, we're asking, what's at address number 0? And just like our map shows, the computer comes back with the very first character, that capital S. So what if we wanted the last letter in Sammy? Easy, we just count from 0. S is 0, A is 1, M is 2, the other M is 3, which means Y is at index 4. And bam! SS4 gives us exactly what we want, the Y.
And this is absolutely the most important thing to drill into your head. In programming, we always start counting from 0, not 1. It's a concept called zero-based indexing. Forgetting this is probably the #1 mistake beginners make, but hey, now you know the secret.
All right, so counting from the front is easy enough. But what if you had a huge string, like a whole book, and you needed the very last character? Counting all the way from 0 would be a nightmare. Thankfully, programmers thought of a really clever shortcut.
Okay, check this out. We've upgraded our map. We've added a second row of numbers. It turns out that every character doesn't just have one address, it actually has 2. One from the front and a negative one that counts from the back.
This is negative indexing, and it is so useful. It's also beautifully simple. The very last character of any string is always at index -1. The second to last is -2, the third to last is -3, and so on. You never even have to know how long the string is.
And this is where you really see its power. You want the last character? You just ask for SS -1. That's it. No counting needed, it's clean, it's fast, and it always works.
Let's try one more, just to make sure it sticks. What if we want that R in Shark? Well, we just count backward from the end. The exclamation point is -1, the K is -2, so the R has to be at index -3. And as you can see, the code agrees.
All right, we've totally mastered grabbing single letters. That's awesome. But what if you want a whole word? Or maybe even a whole phrase? For that, we need a new tool. We don't just index, we slice.
Slicing is exactly what it sounds like. We're going to take a slice, or a chunk, out of our string. We do this by defining a range using a colon right inside those square brackets. All we have to do is tell the computer where to start our slice and where to end it.
So let's try to grab the word shark. If we look at our map, we can see the S starts at index 6, so that's our starting point. But wait a second. The K is at index 10, so why does our code say to end at 11? This brings us to the golden rule of slicing.
Here it is. This is the key. When you slice, the character at your starting number is included, but the character at your ending number is excluded. The slice goes up to, but does not include that final position. So 6 by 11 really means start at index 6 and grab everything until you get to index 11.
Now, slicing also has some cool shortcuts. If you want to start a slice from the very beginning, you can just leave out the first number. So :5 is just shorthand for start at index 0 and go up to but not including index 5. It's a nice little time saver.
And you guessed it, the same thing works for the end. If you want your slice to run all the way to the very last character, just leave the end number out. 6 colon just means start at index 6 and grab everything else, all the way to the end.
Okay, I know this might all feel a bit abstract, like we're just playing with numbers and letters, but these are the real-world building blocks for pretty much anything you do with text and programming. Let's bring this down to earth with a simple, practical example.
Okay, imagine you're given an email address and your job is to pull out just the username. You know the username is everything before the @ symbol. In this case, user is the first 4 characters. Using what we just learned, we can slice it out instantly. Email/4. Done. Simple, clean, powerful.
So let's do a super quick recap. A string is just an ordered sequence, right? Like houses on a street. Every single character has an address or index. Positive numbers start from 0 at the beginning. Negative numbers start from -1 at the end. Use square brackets to get a single character and add a colon inside to grab a whole slice. That's it.
You now have the fundamental skill to take apart and rebuild any piece of text a computer can read. Honestly, it's like having a superpower to see the hidden structure of the digital world. The only question left is, now that you have it, what are you going to build with it?